Welcome back to The Explainer. Whenever we drive past one of those massive chemical plants, a sprawling oil refinery, or some huge, towering industrial facility, it's hard not to wonder, what happens if something goes terribly wrong here? Well, today we are pulling back the curtain on the invisible shield that actually keeps us safe. We're talking about exactly how experts predict and prevent industrial catastrophes before a single brick is even laid. All right, let's jump right into the roadmap for today. We're going to cover 1. Understanding risk in EIA. 2. Meeting the hazard expert. 3. Identifying the danger. 4. Predicting the worst. 5. Managing and mitigating risks. And finally, 6. Ensuring quality and integrity. Let's get into it. It's kind of the ultimate balancing act, right? We absolutely need manufacturing, energy, and infrastructure to fuel our modern world. But how do we make sure our massive industrial progress doesn't turn into an absolute disaster? That is the critical question we're exploring today. Okay, kicking things off with Section 1, Understanding Risk in EIA, and Harmonizing Development with Safety. So it all starts with the EIA, the Environment Impact Assessment. Think of this as the ultimate regulatory checkpoint. It's a mandatory, multidisciplinary study that looks at the whole shebang, from air quality to socioeconomics. But a massive piece of this puzzle, especially for high-stakes projects, is risk assessment and hazard management. We literally have to identify the probable negative effects of a project under abnormal or accidental conditions and fix them on paper long before they can happen in real life. Now, as you can see here, under the Quality Council of India and the NABET's accreditation scheme, risk assessment and hazard management, abbreviated as RH, is officially mandated as a significant functional area. That means if you're a building, say offshore oil and gas infrastructure, or large construction townships, these specialized risk studies aren't just a good idea, they are absolutely required by law. Moving right along to Section 2, Meet the Hazard Expert, the protagonists of prevention. Because let's be real, we can't just have anyone guessing about chemical explosions, right? Enter the FAE, or Functional Area Expert in Risk Assessment and Hazard Management. These folks are the specialized protagonists tasked with keeping these facilities safe. They're the ones out there walking the site, hunting for hazards, running the hardcore mathematical models, and designing the emergency responses. And the bar to become one of these approved FAEs? It is incredibly high. You need a highly relevant educational background. We're talking a bachelor's in chemical, mechanical, or fire engineering, or a master's in toxicology or industrial safety. On top of that, you need a minimum of 3 to 5 years of overall experience, with specific experience in EIA-related risk assessment. And crucially, they have to be absolutely proficient in advanced consequence modeling software. It takes immense technical prowess to do this job. Which brings us to Section 3, Identifying the Danger. Basically, mapping the minefield. So how do they actually do it? Well, the expert uses a super systematic 3-step methodology. First step, they establish the baseline context, looking closely at the surrounding environment, checking for nearby schools, existing pipelines, or seismic zones. Second is HAZID, or hazard identification, where they list every single thing on the site that could possibly cause harm. And third is the HAZOC, which is a much deeper dive into the actual processes and operability of the plant itself. Let's zoom in on that HAZID step. The expert systematically categorizes hazards into chemical, physical, or natural threats. For instance, is there a risk of a toxic gas release? What about a physical vapor cloud explosion? Or a natural disaster like an earthquake in seismic zone V? For every single hazard, they map out the likelihood of it actually happening versus the severity of the consequence. And that lets them assign a strict risk priority. But then we get to the HAZOP study, and this is where they go incredibly deep. FAAs look at the blueprints of industrial pipelines and nodes to predict equipment failure before the plant is even built. They use specific guide words. They'll literally look at a pipe on the diagram and ask, okay, what happens right here if there is more pressure than designed? Or what happens if a valve snaps and there is no flow? It's a rigorous brainstorming session that uncovers all the hidden vulnerabilities in the system. Section 4, Predicting the Worst. Time to look into the FAE's crystal ball. This brings us to a huge concept, defining the absolute worst-case nightmare scenario that could realistically happen. This is known as the Maximum Credible Accident Scenario, or MCS. The expert figures out this scenario, say a catastrophic rupture of a 10-ton chlorine storage tank. Because the logic is, if we can prepare for the absolute worst, we can definitely handle anything less. And to figure out exactly what that nightmare scenario looks like, the FAA uses quantitative risk assessment, or QRA. I like to think of QRA as the FAA's superpower. It allows them to draw an exact radius of danger around a facility. It's not just an educated guess, it's hard math predicting exactly how far a toxic cloud will travel or how intense the heat from a fire will be at a very specific distance. To do this, they plug real-world data, like tank pressure, hole diameter, and wind speed, into advanced consequence modeling software like Fast Micro, Safety, or Aloha. These tools spit out exact distances. They tell us exactly how far a toxic concentration level will reach, how far the thermal radiation from a pool fire or jet fire will burn, or the overpressure blast wave distance from a vapor cloud explosion. Ultimately, this generates risk contours, actual maps that prove whether an accident would harm the surrounding public and if the evacuation zones are actually adequate. All right, on to Section 5, Managing and Mitigating Risks, Designing the Safety Net. Now that we know the risks, how do we stop them? That is where the Environmental Management Plan comes in. The risk portion of the EMP is essentially the ultimate shield. It transforms all that terrifying risk data into a comprehensive, actionable, and fully budgeted strategy. The expert dictates exactly what hardware, software, and human protocols must be installed to neutralize those risks entirely. And we are talking about heavy-duty, life-saving hardware here. The EMP will mandate systems like automatic emergency shutdowns, along with advanced gas, flame, and smoke detectors. It requires physical safeguards too, like secondary containment dikes built to 110% capacity around massive chemical tanks. So if the tank fails, the dike catches the entire spill plus some. Plus, it demands highly detailed on-site emergency plans for the workers and off-site emergency plans fully coordinated with district emergency authorities to protect the neighboring towns. Finally, Section 6, Ensuring Quality and Integrity. Bulletproof Accountability. Because human lives are literally on the line, the NABET scheme demands that consulting organizations operate under a strict quality management system, or QMS. This serves as the regulatory backbone that keeps these organizations completely accountable for their safety data. It ensures that every single calculation, site visit, and safety recommendation is accurate, verifiable, and entirely up to code. And this QMS builds an absolute bulletproof audit trail. We've got a 3-tier system of manuals, procedures, and work instructions. FAEs are required to maintain mandatory field logbooks of every site visit. Data collection has strict preservation protocols, and they have to use recognized, accredited testing laboratories. Finally, facilities must conduct routine mock drills and third-party safety audits. Because, let's be real, the math on the page doesn't mean a thing if the safety systems fail in real life. So yeah, it is a massive, rigorous, and absolutely vital process. Next time you drive past one of those towering, complex industrial facilities, don't just look at the pipes and the smokestacks. Ask yourself, who is the functional area expert who sat down, predicted the absolute worst-case scenario, and made sure you and your community are safe today? Thanks for tuning into this explainer, and keep asking the big questions.